so just a bit of, folks, I'm just recording this, okay, for anybody that's off. So your assessment is on this Thursday. It's obviously when we normally have you, periods 1 and 2. Okay. I'll just check how long it is lasting. My list here. Okay, it is lasting 45 minutes. All right. So if you come to class, I'll give you just a couple of minutes to get yourself settled, look over a few things. So we'll probably start at 9:15 then, okay? All right. So as you know, there are 4 sort of broad topics. I'll just remind you exactly what. Hold on, let me just check this here. Okay, so in terms of the heart, we're talking about the structure and the function. So make sure you know how to label what chamber are the top chambers called? Oliver? Atrium. So which one is that I've put the A in, Lois? Is that the right or the left? The left atrium. What do you call the blood vessel that brings blood to the left atrium, Lily?
Pulmonary artery.
Okay, well, pulmonary. Arteries take blood away from the heart, so it must be the pulmonary vein. Okay. And then, as you know, we've got, what's this structure here? Or here? What are they? Valves. Generally, what do valves do? They prevent... Yeah, they stop blood from flowing backwards. So that happens when they're closed. When they're open, they allow blood to flow from there to there. When they close, they prevent backflow of blood from, what's this chamber down here? Harry, what's that chamber down there? I put the big red blob in.
The left ventricle.
Yeah. So that when they close, they prevent blood flowing backwards from the ventricle back into the atrium. Okay, where else would you find valves? Well, there are 2 blood vessels here and here. So you've got a blood vessel going up there, a blood vessel going up there. Now they cross over usually, so you need to look closely at diagrams to see are they going straight up or are they actually drawn the way they are, where they sort of cross over. So the way you work it out, the one that's coming from here is going to the lungs. So that's going to be the pulmonary artery. The one that's coming from there is the aorta, and that's going to the rest of the body. Okay, what do you call the main vein that brings blood back to the heart? Vena cava. So we've got vena cava, pulmonary vein, 2 veins bringing blood back, pulmonary vein bringing it from oxygenated blood back from the lungs. And then the 2 arteries are the pulmonary arteries taking it to the lungs and the aorta taking it to the rest of the body. So we said there are also a set of valves in there. Okay, I've just drawn them on diagram there. Again, when they open, they allow blood into the pulmonary arteries, into the aorta. When they close, they prevent the blood flowing back into the ventricles. Okay. When you get asked questions, always look at the number of marks. Because sometimes questions that, well, for example, a common question is talking about the thickness of the wall. Okay, so compare the thickness of the left and the right ventricle. Well, you'd say the left ventricle has a much thicker wall. But if there were 2 marks for it, what would you say? You need to give more information. It has a thicker wall because it has to pump blood further around the body. Where does it pump it to? Well, all the way around the body. Where does the other ventricle, where does this ventricle, the right ventricle, pump blood to? The lungs. Okay, so always make sure you have enough information to get you the 2 marks, the 3 marks, or whatever. And if you're in any doubt, give more information than you think. All right? So, structure and function of the heart. Puberty, including the menstrual cycle. So, what are the hormones what are the female hormones? Estrogen and progesterone, okay. And what happens during the menstrual cycle? Well, you've got ovulation. What day does that normally occur? 14. And that's when an egg is released from one of the ovaries. Menstruation, usually days 1 to 5, but obviously it can vary. But it's at the start of the cycle. You need to know that is when the wall of the uterus breaks down, passes out of the body. And after day 5, then the wall starts to build up again. So that around day 14, if the woman became pregnant, then the little ball of cells, the little embryo could implant itself. So it's preparing for implantation. So if she ovulates on day 14, so we're saying that's usually when ovulation takes place. This is menstruation at the beginning. So if you were looking at the wall of the uterus, days 1 to 5 is going to break down. And then it starts to build up gradually so that by day 14 it's reasonably thick. It keeps building up and then it should stay as far as 28. What happens on day 29? Well, day 29 we go back to the beginning. So after that, if you were looking at another cycle, normally it would drop down on the next 5 days and start to build up. If she became pregnant, so say the little ball of cells implants at around day 14 or 15, that's going to affect the hormone levels. And this is not going to happen. First sign that someone might be pregnant is usually that they don't have their next period and they're going to do a pregnancy test. So if someone was pregnant, that would stay high because you don't want the wall of the uterus coming off and moving out of the body. Okay, so let me see. Genetic engineering. We've been through that. Make sure that you know, have a good look at a lot of those questions. You'll see that it's the same sort of things are coming up and up and up. What's the name of the enzyme that cuts open the plasmid? You might have to label a plasmid. Know the steps in genetic engineering. Know what happens in downstreaming. In terms of ethical points, need to know why human insulin made by genetic engineering is better than the insulin that would have been taken from pigs. And you've got some ethical reasons there as well, okay? And then finally, genetics crosses, looking at and so, the kind of things we've done. Make sure you know how to read a pedigree. And by looking at a pedigree, you can work out the genotypes. And I would say have a good look at the pedigree before you just start answering the questions. I would write if you get a pedigree, I would write the genotypes that you know, because that helps you then sort of work things out. Make sure you can do a cross, make sure you're careful about it. But above all, make sure if you're doing a cross, that your writing is neat, that it's easy for the person to see, are you writing a big letter, a small letter, keep it all neat and tidy. If they ask you for genotype, make sure you know the difference between a genotype and a phenotype. Make sure you know the difference between a ratio or the probability. So if you did a cross and you got 3, so you got 3 rollers and 1 non-roller, the ratio is 3 rollers to 1 non-roller, but the chance of getting a non-roller is a quarter or 25%. So the chance or the probability. And remember that, say that family has 3 children and they're all non-rollers. What is the chance that their 4th child will be a roller? Well, what is it? Shout it out. Who thinks it is 1? It's a dead cert. Who thinks it's a half? Who thinks it's a quarter? Yeah. It doesn't matter how many children they've already had. Each time they have a child, it is still a quarter or 25%. So it doesn't matter that they've had 3 children who are non-rollers. It doesn't mean this has to be the last one. It doesn't work like that. If you're doing something like haemophilia or some other kind of sex-linked condition, so we were looking at haemophilia. What is the probability of the child being female? Oliver. Half. What is the probability of having a haemophiliac son? Louisa, what do you think?
25%.
A wee bit louder?
25%.
Yeah, 25% or a quarter, okay? So just, look closely, make sure you've got your head screwed on. Have you any questions about any of those things? Do you want me to go over a few points, or do you want to just sit? You've got 10 minutes left. Do you want to sit and just go through things yourselves? Yes. Yeah, I'm happy with that, okay?